Hi, welcome back to my Intro to Python tutorial series. We're still using this program is Python Online Compiler. You can just Google for it and it'll be the first result. So last time through we wrote this bit of code. What it does is it starts by defining a variable. It goes through and it figures out if that variable's prime. And if it is, it prints out the number's prime. If it's not, it prints out the number's not prime. We have an explicit check for 1 here because 1's not prime and you need to catch it. We go all the way from 2 through to number -1. We check if a mod any number in that range is equal to 0. If it is equal to 0, then we know that we can divide by another number and not have a remainder. So we set is prime equal to false. So if our number was 4, first time through would say, hey, 4 divided by 2 has no remainder, so it must not be false. But if our number was 3, would say 3 divided by 2 has remainder 1. The number, so this part of the code doesn't get triggered. We fall through, and is prime would still be equal to true, and would say 3 is true. So we can test that, and we see 3 is prime, and we see 4 is not prime. We've also talked about functions, which is the idea of being able to reuse code over and over again. So if we wanted to use this over and over again, we could come in here and define a function called isPrime, which would take an argument a, which is the number that we're trying to figure out. We can indent all of this, and the way that I did that was I just highlighted everything and I pressed the tab button. If you press Shift Tab, it'll unindent. That's fairly common through development environments. So we've defined a code block starting at this colon. Everything that's indented becomes part of this function. So we can say print is prime 7. Here, instead of printing out, we want to return true and return false. So what we're going to do is instead of printing something out, we want to let the rest of the program figure out what's going to happen here. So we've defined a function called isPrime. If it's prime, we'll return true. Otherwise, we'll return false. So isPrime 7 is equal to true. IsPrime 8 is equal to false. Cool. Let's put that in a for loop. For I in range, let's go from 2 to 10. We're going to print I equals string of I. If you forget this string of I and you just put print I equals I, Python will say, hang on a second, I can't concatenate two objects that aren't strings. Concatenate again just means add two strings together. So we tell Python, hey, I meant the string of I. This is called casting I as a string. I'm going to say, and isPrime equals so when we run that, we get this output. I equals 2, isPrime equals true. Cool, so 2 is prime, 3 is prime, 4 is not prime, 5 is prime, and onwards. So how about if we wanted to make a function that finds all the prime numbers up to a certain number? I'm just going to clear away some of our white space here. White space can make your code a little more readable, but I'd like to keep as much of this on the screen as I can. So we're going to def primes up to some number. And we're going to go for I in range from 2 to some number. Now, this is actually going to be some number plus 1. So if we actually want to go all the way up to some number, if we did this, it'll be some number minus 1, because we know if we do range 10, it ends at 9. So if we want to go all the way up to n, we'll just put a plus 1 here. And we're going to do something. We want to build up a list of primes and we want to return them. So maybe what we need to do is start with the empty list. So this is just saying, hey, give me a variable called primes and start with nothing in it. And we'll say if is prime I, primes.append I. And we're going to return primes. So it's going to go through the list. Sorry, it's going to go through the range of numbers from 2 up to, say we pass in 10. For each of those numbers, if it's prime, it'll add it onto the list, and that'll return our list of primes. So if we wanted to print primes up to 10, and again, I've got a typo here. I'm going to run it just to show you what happens. We see this name error, name printen is not defined. So that just says, hey, look through your code, look for this typo, and fix it. Cool, so we can see that the primes up to 10 are 2, 3, 5, and 7. We know that 1's not prime. We know that even numbers aren't prime. So the only odd number missing here is 9, I think, and it's divisible by 3. So that looks pretty good. We can print the 9 primes up to 100. That was pretty quick. Print the primes up to 1,000. That was pretty quick. Eventually, if we do this, remember, we're going through each number between 2 and this number. And for each of those numbers, we're going through the numbers between 2 and that number minus 1, and we're checking if it's divisible. So we've got n squared operations going on here. So for 10, we've got somewhere in the order of 100 operations. For 100, we've got 100 times 100 is equal to 10,000. For 1,000, we've got 1,000,000 operations going on. So as your list of numbers that you're checking grows, the list of operations that you're doing grows, on the square of that number. So pretty quickly, we're going to get to a position where, yeah, we've got a bit of a wait here. So I'm going to fill this in by talking hopefully, because 1,000 didn't take too long. So I'm going to hope that 10,000 takes maybe 10 seconds, and it does. But we know if we went to 100,000 here, it's just going to take a ridiculous amount of time. So Python's not the place to do heavy mathematical crunch unless you're using libraries that are specifically intended for it. And we'll talk about libraries later. If you want to do that, there are great places to do it. Java's pretty good these days. Go, Rust, old me would have said C or C++. I still reckon that every serious programmer should learn C, C++, and assembly, but that's not for this. This is an intro to programming tutorial. So just realize that if you're doing some mathematical stuff, you run up against some, hang on a second, my computer's not answering my question, you might want to consider either another way of approaching the problem or somewhere else to do it. So that's our isPrime function. There are some optimizations that we can make here. We don't need to go all the way up to A. We can go about half the way because 4 is divisible by 2, but there's no way it's going to be divisible by 3 because it's more than half the number. So we can come up to something like A divided by 2. That's going to give you some problems. So we can come up to something like int A divided by 2 plus 1. But we'll leave that for another conversation. Next video, we're going to go through a really cool approach of finding all of the primes up to a certain number using a sieve. And the next video is pretty much skippable. It's just a bit of cool maths. The one after that is going to be setting up Jupyter notebooks so that you can run Python on your own computer and see some cool graphical outputs.